Hello everyone, welcome to Nrcm. I'm going to discuss about operating system subject of Unit 1, and the topics are like types of operating system, which is of part 2. Part 2 is nothing but like today we are going to discuss about like multitasking operating system, and second one is real-time operating system. So now we'll be discussing about the multitasking operating system. So here comes the multitasking operating system. Here you can call it as multitasking operating system or time sharing operating system. Both are one and the same. So first of all, the multitasking or time sharing operating system, it is a logical extension of multiprogramming. Multitasking, it is the ability of an operating system to execute more than one task simultaneously on a single processor machine. So we say like in reality, like no two tasks on a single processor machine can be executed at the same time. So actually what happens when CPU switches from one task to the next task so quickly that appears as if all the tasks are executing at the same time. Like more than one task can reside into the same CPU at one point of a time. Like coming to the general example, as you can see in the diagram, like if this is a system or if this is a computer, forget about the operating system. So you're working on like you have opened the different tabs. First is like word processor tab, second is like your email, you're checking on your mails, third is open some web browser like you want to download something like that, or and next is like antivirus, it is in updating state. So now these are different types of operating, these are different types of processes. Like if you want to edit any of the word, this is one process. So two, three, four process are there. Means you have opened four tabs, or you're working for four in for you're working for four things at a time in simple. So we'll be thinking like all the four tabs or four works are simultaneously executed, or they are processing in the system, but this not happens. Actually what happens, so only one I mean this is called as context switching, which will be discussed in the later videos. But just remember this, like even though if you are opening like 4, 5, 6 any of the tabs, so here the operating system will be working, or it will be working on each process. Like it will be giving some time to work on each process. Like suppose like it will like if this can be given as like time quantums. This time quantums is like to execute the word process might be 2 milliseconds, and the time quantum for executing the email might be like 2 milliseconds, and next is 2 milliseconds, and next is 2 milliseconds. So here it will eventually share the time to execute all this work, but it will not simultaneously execute all the works. It will not process, it will give, I mean it will assign the time quantums to each of the work or each of the process, and it will be executed in the way. So the main advantage of this time sharing operating system is like you can say quick response. Yes, as soon as you open the word processor, like the cursor will be stopped. I mean the cursor will be waiting for you like where you have stopped. And if you open the email, or I mean like your mail, I mean the mail, if you want to send or if you want to do anything, any of the operations into the email, so that will be responding. So quick response, if even though there are 5 to 6 tabs, whichever the tab you have opened, the response will be very fast. And it reduces, the main thing is it reduces the CPU idle time. The CPU will not be idle, it will be just switching on from one task to other task. It will be just switching on, and it will be just continuing its work. And next, it avoids duplication of any of the software. So these are the three advantages of this multitasking or time sharing systems. So and the disadvantage is like security. It may like security and integrity issues might be occurring, and some reliability issues also might occur, and some problems on data communications might occur. So to overcome all this in multi-programming environment, what CPU uses is scheduling algorithms. So computer systems that were designed as a batch systems have been modified to time sharing systems. And actually time sharing systems or like multitasking systems are even more complex than the multi-programmed operating systems. Like in multi-programming, what happens? Several jobs must be kept simultaneously in memory. Several jobs will be simultaneously in memory. But here coming to this, like time sharing, so only one process will be kept in the main memory. So that is the only difference. And this is about the time sharing. And next we'll be speaking about the real-time operating system. Real-time operating system. So it is defined as a data processing system in which the time interval required to process and respond to inputs is so small that it controls the environment. In real-time operating system, so the response time should be very fast. Then only for that kind of systems or that kind of embedded systems we can implement or we use this real-time operating system. These are like rigid time requirements. These are like rigid time requirements on the operation of a process. So the real-time operating system, they must be well defined and they should have fixed time constraints. Otherwise, the system will fail. Generally, like examples where we can use the real-time operating systems are like in scientific experiments, medicals, industrials control systems, some weapon systems, air traffic control systems, etc. And this real-time operating system is being subdivided into two parts. First one is hard real-time system and second is soft real-time system. So speaking about the hard real-time system, here the time constraint is very important. So it is like suppose for example, users expected the output for the given input in 10 seconds. Then the system should process the input data and give the output exactly by the 10th second only. Okay, so if here what is the deadline? Deadline is like 10th second. At the correct at 10th second, the data should be processed and the output should be produced. So it should not give the output by 11th second or by the 9th second. It should not be the above the deadline or below the deadline. Exactly by the 10th second, it should give the output. So here, that's why meeting the deadline is very important. If deadline is not met, the system performance will fail. This is the main important thing, constraint. Like another example is like missile. Like suppose if you want to launch a missile and it should reach its destiny at 4 p.m. I mean, it should reach the ground at 4 p.m. So just assume what if the missile is launched at the correct time, like it has reached the ground by 4, but it reached the destination ground. It is reaching down is different and reaching the destination ground it is different. It has reached by 4, 3 or 4, 5. So because of the performance of the system, that is 3 to 4 minutes of delay, the destination might change. There is a problem with like the destination might change from one place to another place or even to another country also. So that is the reason main in hard real-time operating system, the deadlines, it should meet the deadline, else will the output will be in unpredictable manner. So this is about hard real-time system. Next, coming to the soft real-time system, here deadline is important. It should be considered or and but not exact. I mean like 1 or 2 minutes like above the deadline or below the deadline is also okay. But here also it cannot miss the deadline for every task. Each time you cannot miss the deadline. If each time if you miss the deadline, the system performance will be worse and cannot be used by the users. So by giving the example, I think you can understand the soft real-time systems like personal computer, audio and video systems. As soon as you switch on the system, so sometimes it might take some time to open the screen. open. So I mean, if 1 or 2 minutes of delay, like not 2 minutes, 1 or 2 seconds of delay, it will not affect the system. But coming to the hard real-time systems like the missile, the rocket launching, so every minute is countable. So this is about a soft real-time system. So this completes the types of like operating systems. So first, in the previous video we have discussed about like batch operating system and then multi-programmed operating system. And now in this video I have discussed about like multitasking or time sharing systems, and this is real-time operating system. I hope you all understood and you're understanding the concepts. I'll come with the next video, and thank you.